Hey peeps, it's Jedd here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're going to deal with a number sequence specifically related to some sort of geometrical pattern. So we've been told that Samantha is investigating a pattern of dots represented in the diagram below. So in the first one we've got 1 dot, then in the second one we've got 4 dots, and in the third one we've got 9 dots. So they've asked us to write down, so I'm going to write down 4.1.1, okay, the number of dots in the fourth pattern. So I can clearly see that there's some sort of special sequence that's developing here. 1, 4, 9. Those are special numbers. Why? Because they are perfect squares. So in our fourth one, we know that it's going to be 4 squared. So 4 squared is equal to 16. So that's going to be the answer for the fourth term. 4.1.2. Okay, so 4.1.2. They've asked us the number of dots in the 13th pattern. So again, it's just going to be 13 squared equals 169 because we've spotted that it's a special sequence. And then 4.1.3. So 4.1.3. That's a formula for the number of dots in the nth pattern. We've already seen that all you do is you take the pattern number and we square that. So it's going to be, if the pattern number is n, it's going to be n squared. But now let's write that the way they would like us to write it. So typically it would be Tn is equal to n squared. Okay, really nice. Now they've asked us in 4.2, hence or otherwise. And remember when they use the word hence, it means look here. Okay, look here. So they've given us the special sequence of 1 plus 3. So they've said 1 plus 3 plus 5 plus all the way up to 43. Okay, so let's see how this one works. Right, so I'm going to come up with a term or a general term to try and figure out how many terms get us to 43. And you'll see why that's useful now. So let's say Tn is equal to, we can see that there's a common difference immediately of 2. So we immediately write down 2n without thinking too much. We then check what we would need to add or subtract to this in order to get to our 1. So if we subs in the first term, 2 times 1 would give us 2, but we need to get to 1, so we would need to subtract 1. Let's test that with the third term. So if we put a 3 in over there, 2 times 3 is going to give us 6, minus 1 gives us 5, so we know we are completely right. Now let's subs in 43 as our term. So 43 equals 2n minus 1. Let's solve for n. We take the 1 across. That's going to give us 44 equals 2n. We then divide both sides by 2, and that's going to give us 22 equals n. Why is 22 useful to us? Well, let's have a look at our pattern over here. We see that if we've got one term, okay, so if we've got one part of the sum over there, we would have 1 squared. If we've got 2, then we've got 2 squared. And if we've got 3, then we've got 3 squared. So this 22 means that we've got 22 terms being added to each other. So we can now use our total dots. So we would know that the total dots is going to be n squared. And if we multiply, or if we subs in now 22 equals n, so 22 squared, that is going to give us an answer of 484. All right, so nice and tricky, nice and complicated, getting the brain working nicely. Very special thank you to our sponsor for making this video possible. Remember to check out our website for more of these epic tutorial videos. If you can't find the answer to your question, remember you can send the question to us and we'll respond with a personalized video just for you. Until the next time, stay epic.